Hi, everyone. Good morning. I think Tracy is going to be here in just 1 second to start the introductions.
Hi, Dan. It's Tracy. I'm in. You can hear me, right? Okay?
Definitely.
Excellent. Okay, sorry about that. And hi, everyone, and welcome to a webinar hosted by the Cloud Standards Customer Council. This is Tracy Berardi, Program Manager of the CSCC. Apologize for that slight delay. I had a technical difficulty. But I'm here with Dan Kohn. He's the Executive Director of the Cloud Native Computing Foundation. We're very excited to have him with us today. So the Cloud Native Computing Foundation is an open source community run by the Linux Foundation. And Dan's going to give us an introduction to CNCF, and then we'll explore Kubernetes and other container technologies that he's helping to develop under the CNCF umbrella. Dan will talk more specifically about migrating legacy monoliths to cloud-native microservices architectures on Kubernetes, and then lead us into a discussion of how safe is our code. So I'd like to point out in the BrightTalk screen, we have an attachments and links section. You can download a copy of the deck from today. There's also links to the CNCF website and the landscape page where you can see all of the projects. You're also welcome to submit questions. We'll leave some time at the end, about 10-15 minutes, to address those, and you can submit those through the questions tab. And great, I think, Dan, it's over to you. Thank you so much for joining us today.
Oh, absolutely. I'm thrilled to be here. And I will say that I'm aiming to cover a lot of material. And so I'm going to go pretty fast through this, but then I'm hoping to have about 15 minutes at the end to ask questions. And so I would be happy to then address any of those. And then I'm also available for follow-up by email and on Twitter and such. So let's go ahead and dive in. You can see that the CNCF is a nonprofit. We're part of the Linux Foundation. We were founded just 2.5 years ago, but have had a really amazing trajectory since then, where we now have all of the biggest public cloud companies in the world and all the biggest enterprise software companies, and dozens, really hundreds now, of innovative startups that are all collaborating. We are hosting 22 projects as of today. 16 of those, well, as you can see here, 1 graduated, the best known Kubernetes, 15 incubating, which means that they're stable and worth working with, but are still maturing, and then 6 sandbox projects that we have here on the right. These are less mature that are we're trying to point a spotlight at to say that they're worthwhile to investigate. A quick background, if you're not familiar, the Linux Foundation today is more than just Linux across a wide range of technologies. So with Let's Encrypt, it secures more than half the internet. We've combined together all of our networking projects into an LF networking organization. In the cloud, there's CNCF. There's an automotive-grade Linux that's producing the software in all new Toyotas and many other cars and add-ons. With blockchain, we have Hyperledger, and on the web, we have Node.js. And there's actually a number of other projects as well. So it's really it's a foundation of foundations today. I'll give a quick highlight to our end user community. We're up to 221 members, but of those, we're most excited about the 52 in our end user community that are all working with these technologies, sharing their experience. And it's really a pretty amazing group of companies in publishing, finance, a number of startups, Pinterest, Twitter. It's just a really interesting group that we're really thrilled to be able to, that they can share their expertise with each other and with our developers and our vendor members. So just a little bit of background on Kubernetes is, as you probably heard, just had a huge takeoff the last 2.5 years. You can see it compared to some other orchestration hosting technologies on Google Trends, looking at what people search at. And then on the right is WeChat, comparing to OpenStack. And you can see that there's a huge level of interest in China. This is an interesting background on looking at some of the highest velocity open source software projects. Linux remains number one, but depending on how you count between commits and pull requests, Kubernetes is basically number two in terms of the unique number of contributors and how engaged they are. And then, as I mentioned earlier, the different levels of projects, one way to think about that is the mapping to the cliche of crossing the chasm and saying that 2018 we really think is the year that Kubernetes has crossed the chasm. It's now somewhat of a safe default choice for the early majority. Not to say that people are using it ubiquitously across their companies, but I'd say most Fortune 500 companies, most startups are seriously considering it or using it in some way. Then incubation somewhat maps to these early adopters that are looking for what the next thing is, and sandbox projects are much earlier stage, mapping to those innovators or techies. CNCF itself, I jokingly call our governance diagram here our three-ring circus. We have a governing board, mainly of the vendors that manage me and our budget. We have an end user community on the right of those 52 companies I showed a second ago. And then we have a technical oversight committee, kind of like our Supreme Court. 6 of those members are appointed by the governing board, 1 by the end user community. Those 7 vote on the last 2. And so those 9 members are the only people who can bring in new projects to CNCF or adopt them, help move them along the graduation and maturity path. And so it's an interesting process where we've been able to insulate a lot of our technical decisions from the political and business calculations. Those are top architects, folks like Brian Cantrell-Joyant and Quintin Houle of Huawei, Brian Grant of Google, who really care very strongly about their reputations, are focused on making the right choices for the community. I mentioned our large number of members. Here's our 19 platinums, our 12 golds, the end user members and the end user supporters, academic nonprofits, and then very quickly the 220, we have 150 now silver members. Here's half of them, and here's the other half. So again, just a fantastic number of names here that we're really thrilled to be aligned. Okay, so that's the kind of quick background on CNCF. I'm going to dive in and give one look at these questions of talking about when is Kubernetes appropriate. And so this is a part of the presentation I call my brief history of the cloud. I was a venture capitalist back in the year 2000, and Sun was the absolute dominant company in computing, and people would come and say, well, I have this idea, there were no apps yet, but for a website, I want to raise a couple $1 million so that I can buy Sun hardware, put it in a rack, and try out the app. And so the building block of the application at the time is physical servers. You'd call the Sun salesperson, maybe they'd call you back, and weeks or months later you would have your new servers or racks arrive, and then you could try out the application and deploy it. So the first step in this history is non-virtualized hardware. Next, we have virtualization with VMware. They released for the server market in 2001, and they popularized the concept of virtual machines, or VMs. Now, it is interesting that the companies listed here are almost never the ones who first pioneered a concept. They're the ones who popularized it and made the most money from it. And so the idea, the sort of dark secret of many data centers, is that a number of servers are only running at 3% utilization or 5%. And so the magic is you wrap your application in a virtual machine. You can put multiple VMs on the same physical machine, and now you can buy fewer servers. And so VMware became incredibly, insanely profitable. It hurt Sun. But for our purpose, the key idea is that the architectural building block went from being a physical server to a VM, that the designer started thinking in terms of VMs. So now we go forward to 2006, when Amazon Web Services popularized the infrastructure as a service, or IaaS market, by launching EC2. And this was the really groundbreaking idea that you didn't need to own your servers anymore. You could rent them by the hour. So now, instead of that startup coming to my venture capital firm and saying, well, here's all this money I need for CapEx, that becomes OpEx. But interestingly, although it totally changed the economics, the architectural building block essentially stayed the same. It was still a VM. It was just called an Amazon Machine Image, or AMI. Then we fast forward to 2009. Heroku popularized the concept of a platform as a service, or PaaS. They defined a building block of a build pack, they described what it means to be a 12-factor application. Now, interestingly, build packs are really just containers, although they're opaque to the developer. But the magic here was sort of, for many of us, giving us our first taste of DevOps, that you would make some change to your code and you could just type git push Heroku. And 2 minutes later, you would see the updated version of your app live. And it really was a groundbreaking, just complete change, paradigm shifting, I'll even say, change in how applications could be deployed, to realize that you didn't have to deal with all of those different aspects. Instead of having a deployment occur every quarter or every month or every week, that you can do dozens and dozens of deployments per day. Okay, so we're halfway through our history. And what's interesting is that the first 4 stops here were all closed source proprietary companies. The next 4 are all going to be open source. And so in 2010, OpenStack formed. Originally, Rackspace and NASA were the 2 backers behind it. The easiest way to think of their ambitions is that they wanted to compete with VMware and AWS and create an open source alternative to it. And I would say that ultimately they were completely successful in that. And now it took a little bit longer than they hoped it would. And, there's always a few years there where you're trying to get the software to be mature and other kinds of issues and politics and things come along. But I think they were very successful in that. But I will emphasize that the building block of how you build your software with OpenStack remains the same, which is a virtual machine. Then in 2011, Cloud Foundry came out with essentially, a competitor to Heroku. There's some subtleties and some details, but it was really all based around this idea of a 12-factor application. They open sourced it in 2014, and in fact, Cloud Foundry is a sister organization of CNCF, hosted at the Linux Foundation. Then in 2013, I'd say was a real surprise, where you had Docker come along and popularize the concept of containers. And what's interesting is that it combines together at its core 3 critical technologies, LXC and C groups, which are both ways of isolating processes, and a union file system. And these had all been developed separately by different folks from IBM, Google, some universities and others had been contributed into the Linux kernel. And I draw the analogy sometimes to Solomon Hykes at Docker, where it's a little bit like Tim Berners-Lee with the World Wide Web in 1990. And you say, well, what was really that novel about the World Wide Web? It was HTTP, which is basically just an optimized version of FTP, and HTML, which is just a subset of SGML, which had already been around for 15 years, and URLs, which aren't that novel. It's just the idea of a single text string for setting an address. But sometimes when you combine together existing technologies with a user interface, magic happens. And I think it did with the web, and I would say that it did with Docker as well. And then it was really trying to solve a fundamental issue that comes up a ton, where you hire the new developer on board and you give her the install instructions and probably a Mac, and she's going through the steps, and halfway through she gets an error message and just can't go any further. So she goes to the experienced developer, maybe has a long beard, and says, hey, I got this error message, can you help me out? And he says, yeah, it works for me. And so the idea of Docker is that experienced developer has encapsulated their whole development environment into a Docker container. And when the new person starts, it's just minutes for her to download and install that Docker image, and she has exactly replicated that existing environment. And my claim here, I don't quite know how you would prove it, is that it's the fastest uptake of a developer technology ever. Within a couple years, almost every organization was using Docker in some way. So it enables isolation, reuse, and immutability. And so it had this huge uptake in development, but then it raised the question, okay, well, this is making my development environment easier. Why can't I use these same containers in production? And that brings us to the last step of our history, cloud native, where we define cloud native computing as using an open source software stack to segment your application into microservices, and I'll talk more about that. You package each part in its own container, and then you can dynamically orchestrate those containers to optimize resource utilization. And of course, Kubernetes is the platform that most people today are using for that orchestration. So let's look back through this history. The core building block of how the software is being developed and deployed went from physical servers to virtual machines to build packs to containers. The isolation units went from heavier to lighter weight, going from weeks to get a new Sun server installed, minutes for VM, and generally seconds or even tens of milliseconds for spinning up a container. Immutability, going from pets to cattle, that as opposed to treating each server individually, you can label and manage your containers en masse. And then the provider went from a closed source single vendor to open source cross vendor. Okay, so this is this crazy diagram. I am going to spend a little bit more time on it later, but it's just saying that there's been this explosion in interest in cloud native environment and opportunities. And I will point out it's l.cncf.io if you want to get a high-res version of this and start clicking through it. But the question is why, what are the benefits? Why do people care about these things? So number one is the ability to avoid vendor lock-in. When you standardize on Kubernetes, it enables deployment onto any public, private, or hybrid cloud. That is, you can use exactly the same environment on any of the big public clouds, including many small public clouds, on your own bare metal on-premise hardware, and then a number of companies today are beginning to work on hybrid cloud deployments where it might be more cost-effective for you to have your base load on your own servers, but you can burst up on the public cloud for the extra demand. Next is unlimited scalability, so being able to go from several nodes on your laptop to tens of thousands of self-healing multi-tenant nodes. We announced this month that JD.com is a new platinum member of CNCF. They have 20,000 servers running Kubernetes. Their largest cluster is over 5,000 servers. So it really is designed for almost unlimited scalability. Then the increased agility and maintainability is where we talk about microservices. You divide your app up, and now you don't have to have the same version of library. If one part of your app needs a new library, you don't have to update it across everything. And critically, as your development teams get larger, each of them can work on their own portion of the app, have an API for the rest of them, and try and maintain that contract. And it's essentially the only way that large companies have found to successfully scale. Increase efficiency and resource utilization. This is the orchestration concept that Kubernetes provides. So instead of trying to manually allocate workloads to servers with specific functions, instead you declaratively describe, okay, this application needs access to a GPU, this application needs this kind of storage, this one needs this much network and CPU performance, this one needs to have at least 5 copies of it running at all time, and then Kubernetes can automatically assign out all of those applications, all those containers in the correct environment. And it essentially just gets in a control loop where it's constantly, it knows the environment, the rules it's supposed to be following, it looks at what reality is, and then it makes the changes to adjust one to meet the other. And that allows for significant improvements in resiliency. So it's Kubernetes is really designed that any individual container can die, any individual machine, even entire data centers, and critically to varying levels of demand. So that ability to scale up very quickly when you have a flash crowd, but also scale down where the demand isn't there. So this whole cloud native environment enables significantly higher performance. Puppet has done a nice job looking at the fact that these high-performing teams do 200 times more frequent deployments, thousands of times shorter lead, 3 times lower change failure rate, much faster recovery from failures. And so looking at if you're building a new application from scratch, a greenfield application, I think we can confidently say that cloud-native application architectures are the default choice for those greenfield applications. And the leading choice for cloud-native orchestration is Kubernetes. It's been selected by tons of top enterprises and startups, like the 52 I showed earlier. It's one of the highest development velocity projects in the history of open source. There's an amazing group of technology giants and startups that are cooperating to improve it rapidly. Okay, so we're done, and we can end this talk at 40 minutes early, except for this quote, which I do love, from John Maynard Keynes. In the long run, we are all dead. Economists set themselves too easy, too useless a task if in tempestuous seasons they can only tell us that when the storm is long past, the ocean is flat again. So I just love this phrase, too easy, too useless a task. Because the real world and most of your companies consists of brownfield applications. The gross world product, that's everything that's sold in every country, is about $100 trillion. And almost all of it flows through brownfield applications. Even Google still has monolithic, old-time applications for doing a lot of essential tasks like payroll and probably ERP and other kinds of things. And those brownfield applications are generally monoliths. So hopefully some of you get the 2001 reference, monolith as a term for a really big app that does a ton of different things that's very hard to make changes to. Maybe the test coverage isn't very good, that you're really worried about how do you improve it without breaking anything. And so the one obvious answer is a rewrite. And the problem here is a nearly 50-year-old book called The Mythical Man Month, which described a term called the second system syndrome. And it says that many rewrites end in failure. And the underlying problem is that the existing system needs to keep evolving if you have customers with new demands that you're trying to address. And that often happens faster than the second one can catch up with. Okay, so monoliths are the antithesis of cloud native. They're inflexible, they're tightly coupled, they're brittle. The key question that we're trying to ask here is, how can you evolve that monolith into the cloud native future? And step one is to stop digging. That's saying that if you have a monolith, is to realize that this is a problem. It's causing you the development velocity of your enterprise to be far lower than it should be, and to look at how you can evolve and start making changes. And then step two is to lift and shift your monolith. So people think of containers as being these svelte things that just have a single application in it that can be super tiny and, you know, maybe just a few 100 kilobytes in size that spins up instantly, etc. And that absolutely is the aspiration, and that is the goal, to have lots of different containers where each of them only does one thing. But in fact, any application can be containerized. And my favorite example of this is Ticketmaster, which has 40-year-old COBOL code that is running on an emulator in a container on AWS. And so one of the key technologies here in Kubernetes is called stateful sets, that allows you to pin a container to a specific machine to avoid it having to move around and to get more control over it. Okay, so persistent storage, unique network identifiers. Then, and this is really the key idea of the whole deck, you start chipping away at your monolith. So as different parts of it need upgrades or improvements, instead of just doing development the old way, look at, could you pull a whole piece of functionality out and move it into its own microservice? So, for example, if you're going to be implementing OAuth for the first time, maybe you would prefer to do that as a separate Node.js app that's communicating back to the legacy app for authentication. If you have some performance-sensitive tasks that you want to run, maybe you want to write that in Go. And you really want to start with the stateless services. So Kubernetes can run both stateless and stateful, but stateless is definitely much easier and is really where you want to get started. It's where you get the biggest benefit for things that like application front-end servers that need resiliency, load balancing, auto-scaling. A good example here is Wikipedia, which is running their PHP MediaWiki servers in Kubernetes, but still has their MySQL database running on directly on bare metal on several big servers. And then you want to transition your data stores last. So you can support stateful services like Postgres or Redis. I will specifically call out to a new project that CNCF has brought in called Vitesse. It comes out of YouTube, and it's a very successful way of sharding MySQL or MariaDB to allow it to run well in a cluster environment. But it's definitely not the area you want to get started in. So when you look at complementary projects, CNCF, and we're missing a few of them on here, has a number of them that help provide services that can make your cluster work better, more successful. And continuing the metaphor, eventually, if you keep chipping away at it, hopefully you can turn that monolith into a beautiful microservice, or more likely, a whole collection of them, where each of them is running in their own container and in its own environment, it can evolve with its own team more successfully. So really the point of this talk is to say that you want to avoid the soft bigotry of low expectations, of thinking that you need to do a greenfield rewrite in order to get the benefits of cloud native. We would say that Kubernetes loves brownfield applications. And if you'd like to learn a little bit more about some of the examples that I mentioned here, here's some good links. And we actually have several dozen additional case studies on Kubernetes IO that are really a great way of learning about what other companies have tried and what's succeeding for them. Okay, so that is a little more than half the talk that I want to give. I'm now going to change over a little bit and look at this question of cloud native architecture and how good is our code, and specifically what's the most important part of the cloud native architecture. So this is a year ago, KubeCon, Cloud Native Con in Berlin, and you can see the backdrop graffiti that we had for the super cool round keynote stage. Containerization, orchestration, microservices. I mentioned those earlier as being three of the key aspects of cloud native. And then you can, basically the question we're going to look at here is which of these is the most important. Now, I don't have a way of playing this very fun video for you. I do recommend that you come back after the talk and watch it. It's about Juicero, one of the funniest startups of the last couple years, where they had a $600 machine that would squeeze your vegetable juice for you. And it, the video shows a reporter squeezing it with her hands instead, and she can actually get the results exactly as quickly with her hands as she can from the machine. So anyway, the point of the video and the story is that after raising and burning through $120 million of venture capital, Juicero collapsed last September. The former CEO, Doug Evans, then went on a 10-day cleanse, drinking nothing but live water. What is live water, you ask? Unfiltered, untreated, unsterilized spring water. I haven't tasted tap water in a long time, Doug Evans said. You have to be agile and tactile and be available to experiment. literally, you have to carry bottles of water through the dark. So let's look at the live water of software development. This is a tweet from QNTM. Our new software consultancy produces what we call raw code, guaranteed not to have passed through continuous integration or any kind of onerous testing. The result is a palpably richer and more authentic software experience. But let's take this one step further. I suspect many of you are familiar with SQLite. If I asked how many used it, it would be a trick question because all of us do. It's built into iOS, Android, Chrome, and Firefox, among other things. So our software is not as good as SQLite. SQLite's developed by one highly regarded developer. It has 100% branch test coverage, millions of test cases, literally 1,000 times as much test code as they have product code. And then American Fuzzy Lop came along. Not this American Fuzzy Lop, but a software fuzzer that was built by Michael Zalewski that uses genetic algorithms to find bugs. And when Zalewski ran AFL against SQLite, he found 22 bugs in 30 minutes of work. Now, I want to point out that SQLite quickly fixed all of those and actually even incorporated AFL into their release process to avoid any recurrence in the future. But again, our code is not as good as SQLite's, and the problem is bigger than that. So that brings us to the second question, how big is our application? Because it's not enough to just look at the surface area of the code that we've written, as our app is potentially vulnerable to all the software it depends on, and transitively to all the software that software depends on as well. I did the calculations on an app that CNCF has been building called the Interactive Landscape. So let me give a shout out here to David Wheeler, the author of Slot Count, which is the tool we used. And our app, unsurprisingly, runs on Linux, which is 17 million source lines of code, or slots. It also runs on Kubernetes, which amazingly is now double Linux's slot count at 35 million. Now, for all the software I'm showing here, I want to point out that we're not using a line of code for our installation, but somebody is for theirs. So it's a Node.js app. Node.js is 12.3 million slots, which is 70% the size of Linux. And then, as with almost all Node apps, we depend on a ton of third-party libraries, such as Webpack and Babel. That's 2.5 million slots just for the Node modules directory. And then finally, like the cherry on top, is our code itself for the interactive landscape. That's only 40,000 lines of code, meaning that the NPM modules our code relies on are 63 times more code than what we wrote directly. So if we now graph all of that, we can see this chart, and unfortunately, every part of this software stack is a potential vector for vulnerabilities. And in fact, I left out one part of this pie chart, which is our code itself. It's less than 0.1% of the code that we depend on. Now, we're not the only ones that are looking at this software stack. Unfortunately, there are black hats that are looking for vulnerabilities in every part of our stack, whether or not it is open source. So if we now go through here, we can see that Webpack had a very serious vulnerability called divide concept a few months ago, and these are just a few examples. Node.js uses OpenSSL, and so it was vulnerable to Heartbleed a couple years ago. Kubernetes had a serious vulnerability called subpath earlier this year, and Linux had to be modified to deal with both Spectre and Meltdown this year. Now, stable kernel maintainer Greg Kroll-Hartman made me point out that those are not actually vulnerabilities in Linux. They were fixes in Linux to deal with vulnerabilities in the underlying x86 hardware. But he would also agree that Linux has a ton of vulnerabilities on its own. Now, what's great is that there's the power of open source is that there's thousands of developers that are looking for and actively fixing these kinds of bugs and security vulnerabilities. But we can, the patches that they're making to the software are things we can only take advantage of if we deploy the updated software into production. So how can we have the confidence that we can update our libraries, update Kubernetes and Linux, and that doing that won't break anything? And the answer is continuous integration, or CI. This is just simply the idea of running our tests every time we make a change to our software. Okay, so what kinds of tests should we run? You have unit testing, which looks at individual portions of our source code in isolation. You have integration testing, where we compare it to, run it with databases and the other software that relies upon it. You have regression testing, where we add a test after every failure. And smoke testing, also known as build verification testing. And in fact, there's a number of other kinds of tests as well, such as the fuzzing that I referred to earlier. And so the answer is that we should run all of the above, but we can get started with just a smoke test. That's the idea of turning on a machine and seeing whether smoke comes out. Hopefully not like this. So the idea is that no matter how antiquated the code base we've inherited, we can write some smoke tests that confirm that at least the happy path is functioning correctly. And then we can run those smoke tests on every commit. So let's circle back now to some of our original questions. First, how good is our code? And the answer is not good enough. We need to build in the systems and processes that enable us to continuously improve it. Now next, which of these is the most important? My answer is that a different part of the cloud native architecture is actually the most valuable: continuous integration, or CI. And to quote Kubernetes developer Kelsey Hightower, if you don't have a CI system capable of building your application, then Kubernetes is the least of your problems. Focus on CI first. But let's take this one step further. So continuous integration just means constant testing. But what is testing? Testing is like science. We have a hypothesis of what we believe our code should do, but we don't know for sure until we test against objective reality. So it was actually a philosophy of science professor Karl Popper who defined science as being testable and falsifiable. So now let's look at how does continuous integration fit into the cloud native journey. I just had a little distortion on this slide here. But this brings us full circle. So really, testing is the same thing as science and is also related to entrepreneurship. In each case, we have a hypothesis of our ideal of our idealized conception of how things should work, but we then need to compare that to the brutal reality, brutal truth of objective reality. And so that brings us full circle back to live water and to Doug Evans and Juicero. Because no matter what you believe, no scientific test is going to demonstrate any validity to the health claims of live water. And even if you succeed in raising $120 million, your company will fail if customers feel defrauded by your product. And no matter how great we think our code seems to be, if it doesn't pass a smoke test, we can't deploy it. So anyway, now let's look at that question of how does continuous integration fit into the cloud native journey? And my answer is that it comes second. This is the cloud native trail map. It's available at l.cncf.io. And it's a way of looking at what are the different steps along the way. And we recommend containerization based specifically on experience I had of getting a whole CI/CD environment running before we containerize, and then finding that we basically need to throw that out and start it again. So containerization first, then CI/CD, then third is orchestration, where you look at Kubernetes. And so this is a useful way of thinking through the different steps as you move on into a cloud native path. This is the front side of the document, where this cloud native landscape is the back side. But now let's zoom in to the continuous integration part. And this is a much better way of researching this is to go to the new interactive landscape that I had mentioned before, l.cncf.io. And I encourage you to even step out from the webinar for a second and play with it, or if not, take a look afterwards, where it's really interesting to see your organization's projects on there, to see the offerings from different companies. You can do things like sort by stars for open source projects. You can sort by funding, sort by age, sort by category. And it's a good way of trying to get a feel for the different options here. Okay, so let me just finish up with a couple recent pieces of news, and then I would love to open this up for questions. One thing I want to mention that CNCF has made a major investment into is the Certified Kubernetes program. This is a way of having confidence that the different Kubernetes implementations out there all support the same APIs, and we're thrilled to report that we're up to 58 certified Kubernetes partners, which is a really pretty amazing level of engagement. We essentially have every offering in the entire field has gone through this program and become a certified Kubernetes partner. CNCF runs a free, massively online, open online course with edX. We also have 2 paid training courses, a Kubernetes fundamental and an application developer course. The curriculum for those is available for free. There's links to it here. We also have 2 online proctored exams. This is where you hold your driver's license up to a webcam to show that it's really you, and then go through this 3-hour exam. There's no multiple choice. You're actually addressing real clusters and deploying software, fixing bugs to show that you're knowledgeable about these. We have a program called Kubernetes Certified Service Providers for consulting companies that have expertise, and we're thrilled to have 44 KCSP partners so far. And then I want to mention our events. So we just held our biggest event ever in Copenhagen at the beginning of the month, 4,300 people there from 6 continents. We're going to be holding our first ever event in China in Shanghai, November 14th and 15th. And then our biggest event ever will be in North America in December, Seattle, from 11th to the 13th. And so if you are interested in this space, want to learn more, but also kind of drink from a fire hose, that is the best place to do it. And I'll just finish showing the growth for our events, where we went from 500 3 years ago in San Francisco 4,200 in Austin in December, 4,300 in Copenhagen. So I will go ahead and stop there. Here are a few links to find out about joining CNCF. You can reach me if you just email info@cncf.io. I'll get that as well, and I'm happy to answer additional questions. You can also find me on Twitter. But I'd love now, if you don't mind, in Bright Talk, you can go ahead and ask some additional questions from the audience. I went through a ton of material there. It was 108 slides in about 43 minutes. So I would be happy to answer any questions that come up or tell you anything more about CNCF and our projects and our approach to this space. I did get one comment so far, which I appreciated, that great intro to the comment, the Ticketmaster brownfield use case is worth the price of admission. And I agree, I love that example. That's, of course, the most extreme. They also have tons of other apps that are not COBOL, 40-year-old COBOL. They have Java and really everything, as most large organizations do. But I would particularly point you out to Kubernetes.io and click on case studies. And we're now up to dozens of different examples that are really good way to get a feel for this and look at organizations similar to your own that can give you some useful feedback. So we have 204 folks online. I know there's some questions.
Really great presentation, Dan. This is Tracy. Thank you.
Oh, certainly.
Yeah, I wanted to mention the interactive landscape link. It's also in the attachments and links section there too. That is really cool. Any big highlights from Copenhagen a couple weeks ago? Anything surprise you? Did you learn anything new?
Yeah, that's a good question. I definitely wouldn't say there were any huge shocks. It's always kind of amazing to see the size of the community and everyone get together. I would say that sort of one theme that I think has come up in our last two events is almost complete confidence that Kubernetes is going to be a critical part of the infrastructure, software infrastructure going forward, but also an agreement that the current way of deploying applications of where you build the containers yourself and then can you write some YAML that describes how many replicate copies you need and how it's organized, and then you use a little command line tool, kubectl. There's almost unanimous agreement that that is not the way that most developers, most application developers want to be deploying their application. And so there's a belief that Kubernetes is kind of an ideal set of building blocks for many organizations to build their own paths. And there's now a ton of different tools and a real just kind of bubbling up of different, a Cambrian explosion, you might say, of different tools built on top of Kubernetes that are experimenting with different ways of deploying it. So CNCF just brought in a new tool called telepresence into our sandbox that allows you to directly connect to the cluster and see your changes updated in real time. There's projects out of Microsoft called Draft and Brigade. There's ones out of Google called Kaneko and Scaffold. And I'd say that all of those are extremely early days, but it's really interesting to see the awareness of and the interest in improving that developer experience. In some ways, they're trying to get back to that PaaS environment where, and you know, you can do that where you have the git push Heroku or the git push and then it's hooked into the CI/CD system. But experimenting, playing with many, many different patterns.
And Cambrian explosion, I can see that as one of your new slides down the road. We did get some questions in. Can you talk about the role of crafting APIs in this landscape? Yeah.
Let me just see if I can go back a few slides. And again, I apologize that the landscape is a kind of a ridiculous document at this point with 500 different logos on here. But I think one way of thinking about it is that each layer of the landscape is consuming services and APIs from the layer below it and providing a set of services to the layers above it. And so ideally, you know, CNCF now has in 16 graduated and incubating technologies, but I think it's fair to say that there's no enterprise out there that's actually using all 16 of those technologies today, and no others. That in almost every case, there's either some homespun technology that's meeting organizations' need, or they're using a commercial third-party service, or in some way putting together their own solution. So people do complain about this chart. It's been called useful, it's been called overwhelming, it's been called the hellscape. But I do think it's useful to look at all the different services and offerings that are available from many different sources, and to think of this as a way of kind of picking your API and deciding where you want to consume different services from. I see another question here about recommended approach for Kubernetes horizontal and vertical scaling. And Kubernetes really just has a number of knobs and options built into that for that. And so if you just choose Kubernetes, do a web search for those, you're going to find a number of good options. The pieces that are coming along that I think are most promising on that front, I mean, and Kubernetes does support both out of the box. Scaling sideways as demand increases, or moving to larger machines. There's two technologies, or I particularly focus on. Envoy is a service mesh, and it's a way of, it provides load balancing, routing, takes over a lot of the functionalities that you'd otherwise be using Apache or Nginx for. And the idea is to be looking at the health of all of your different instances and looking at the how much traffic is coming in, and then automatically allocating that correctly. And then there's a new technology, Istio, which is built on top, which is where Envoy is the service plane, Istio is a control plane. And the easiest way to think of it is it's taking a lot of the functionality that previously would have required a system administrator to go do manually and trying to automate that. Envoy is a super mature production grade technology. It came out of Lyft, but is now being used in dozens of different companies. Istio is not. It is not yet production grade. There are a number of people that are playing with it. That's huge ambitions behind it. Really interesting uptake, but it's one of those things that you could deploy Envoy today and start playing with Istio in your lab that can improve the quality of your scaling without, but I wouldn't quite put it into production. Another great question here about paid and enterprise Kubernetes providers that are freezing their Kubernetes versions and not updating them very frequently. And this is actually a really clever aspect of our certified Kubernetes process that I think is actually pretty innovative, where it says that it's totally fine if you certified your Kubernetes with, when we first launched it with 1.7, if you want to continue to offer 1.7 to customers and they want to continue to buy that and stay on the older version, that's totally fine. But in order for it to remain certified Kubernetes, we require that those providers update at least one new version every year. And so that essentially means if they haven't done anything more recently, they need to certify 1.11 and offer that product commercially as well in order for their 1.7 certification to stay valid. And that'll continue every year afterwards. Now, many providers are doing every version or every other version, but the reason we're doing that is to avoid having providers fall off of that release train, that for customers who are interested in moving to newer versions, getting to take advantage of all the new features that come out, we want to ensure that that remains available. And then local meetup and support is a great question, and then a hands-on Kubernetes cloud. So we actually have almost all of those things today. If you go to cncf.io and under the community tab is meetups, and we're, I need to just pop up the latest statistics, but they're pretty impressive. We have 145 different meetup groups in 31 different countries, and 67,000 members. And so hopefully there's a meetup group in your local area that you can join and participate. If not, we'd love for you to start it and engage with it. And then if you go to kubernetes.io under documentation, we partner with a service called Katacoda that does give you, a live Kubernetes environment that you can actually deploy and play with. Now, I think Kubernetes is legitimately criticized. There's a funny phrase here from Sarah Novotny, where in particular when you compare it to Docker and you say, oh, I can just install this and containerize my first app and demonstrate it within a few minutes, that deploying and playing with Kubernetes on your own is a little trickier. And as she puts it, the time to first epinephrine to first endorphins, is a little bit higher, but it certainly should still be within hours, and even if it's not 5 minutes. And I would particularly recommend the new Docker for Mac and Docker for Windows is one of the easiest Kubernetes installations out there. And so if you're just looking to play with it and get a feel for multiple nodes and how you configure it and deploying an application and such, those are real certified Kubernetes installations that you can play with on your own machine and get a feel for if the web option through Katacoda doesn't work for you. And then there's another older product called Minikube that also works quite well, but it's a little heavier weight. I have time for one more question, or else we can call it there.
Yeah, looks like all 5 stars across the board. Thank you, Dan. That was great. I think.
Oh yeah, well I really appreciate, Tracy, the invitation. So thank you very much, and thanks to everyone from the audience for taking the time this morning.
Absolutely, and this will be archived here momentarily on brighttalk.com and also on our website, cloud-council.org, if you'd like to view again or share this with your team. And Dan, I look forward to speaking with you again soon, and thank you everyone for tuning in today. Have a great rest of the week. Bye.
Great, thanks everyone. Bye now.